Welcome to AutoCAD 2016 training series, and this is the most updated and recent release which can directly increase your productivity. And primarily this video training is for everyone who is related to design and engineering solutions where the 2D is the primary key for deciding your manufacturing or the final call to actions, and typically conveying that what you are looking for and what your design is all about. So drawing, release, engineering and drafting is the key fundamental backbone for across the industry, irrespective of the horizontal and verticals where you work. The 2D drafting is quite primary and popular solutions among all the industries verticals. But primarily the way AutoCAD 2006, 7, 8, and after that, in typically they did major changes in 2010, and after that they introduced the parametricity, and primarily the AutoCAD 2000 and the corresponding version like 2008 9 also was non-parametric, and after that when they introduced this parametric feature, the way AutoCAD was conceived was quite different, and it can compete with any of the software. So primarily here our learning objectives are to understand the parametric capability of your drafting and modeling through AutoCAD 2016. The course we have designed by keeping fundamentals to advanced application in mind. We have included industry standard projects to better understand this. And let me introduce about me. I am Pramit Kumar Senapati, subject matter consultant for Smart Learning Technologies Private Limited. And till date, since 2000, I have trained more than 35,000 engineers in classroom and through WebEx and through workshop and different other solutions. And since the last 5 years, I'm involved in more into the online training and the e-learning content. So I'm author for more than 100 plus CAD/CAM CA trainings, and across 55 countries in globe they are using my content. And currently through this new way of teaching, I have trained more than 10,000, not physically or directly by using my content they use, and through the forum they used to connect me and ask for their doubts. And agenda here is who are our targeted audience and what do they do this, and module highlights and prerequisites, and then we'll look into the sample course preview, and then we'll move into the deliverables. Let us start with who are our targeted audience. So if you talk about the targeted audience, this is one of the key and fundamental aspect where you need to get the clarity. So it is always important to know why, who, how, and when to learn a typical CAD/CAM CA package. So here we are talking about a drafting. A new way of drafting is AutoCAD, where the parametricity is the primary key. And what is that parametric? You will come to know, and I'll reveal all the secret related to that within this particular presentation. And who are our targeted audience? Everybody who are related to engineering. Maybe you talk about your design, you talk about your inspection or quality, you talk about the typical GD&T protocol, or you talk about the manufacturing. Everywhere this 2D is being used, and that is the backbone. And I have categorically shown some of the applications or the targeted audience, like the application engineering portfolio, design engineer, CAD, CAE, and CAM as well, and CAD engineer, drafting engineer, development engineer, R&D, product design and development, project team leaders, GM design, all the hierarchy which you can conceive, CAD trainer, and tool and die design, and auto domain, aero domain, SPM, product design, tool design and development, and all the consultants. And it's very difficult to categorically show all the targeted audience, but whatever you can conceive in engineering, starting from your design, quality, inspection, and manufacturing, production, everywhere this particular drafting package is being used. And what do they do primarily? So four important operations they are involved with. So they'll develop new concept and modify the existing. For that, the primary communication when you do that communication is done through this particular 2D, or maybe you can talk about the section drawing, or maybe you can talk about 2.5D, that is isometric. And these are all the ways which we use to produce the design using the advanced digital drafting tool, that is typically 2D and 2.5D, and finally the 3D. And we have higher dimensions also like 4D and 5D, which you can learn in my other solutions like the Primavera and all. So application of CAD CAM CE concept for product design and CAD to CAM, this complete solution is involved, and analyze user needs and develop engineering solution and create appropriate documentation to ensure traceability. And these are the primary uh, portfolios. And for all the shop floor drawings, you primarily get involved with 2D section drawings, aux views, orthographic projections, etc. And the module highlights for this AutoCAD 2016 is given here. And before going through that, you have to understand that you have to get the course details. And this course details is fundamental before learning any course, and which looks like funny because most of the engineers, they never ask for the content or the thing which we're learning or from whom they are learning, and maybe just they're learning. And you have to understand, and we are very serious about what we teach. And these are our modules highlight. So 20 different modules categorically have shown. So introduction to AutoCAD, the getting started with AutoCAD, and advanced sketching option, and working with drawing advanced option, and next editing sketches, the fundamental and advanced, creating text and tables, basic dimensioning, GD&T and its complete features, and editing dimensions, dimension styles, its variable and typical advanced option which is known as the system variable, that will talk more detail, adding the constant. This is very important, and this is one of the new way how the AutoCAD is currently behaving and delivering its products in parametric feature, and hatching drawings, model space viewport, paper space configuration and layout, plotting the drawings, and template creation for your companies and for different purpose, working with blocks, how you can increase the productivity by reusing the objects, defining attributes and the block, very advanced concept, understanding external reference. This is also very advanced concept that we'll be dealing with, working with advanced drawing options, and finally we'll look into the grouping and advanced editing sketch options. So prerequisite is very specific. So you need to understand that 2D is the backbone for any 3D. So this is not just a conversion and visualizing. The first you visualize 3D and then the 2D will be just for your reference purpose. So there is nothing called 2D exists, but this 2D can only be visualized if you visualize your 3D first. So how you can design effectively and how you can visualize and get your 2D sections, that is the prerequisite for this, and you need to master the very fundamental basics of engineering drawing. And this is what is the fundamentals before beginning any further exercise. And let us have a look at our sample course preview. And here we'll be looking at the constants and equations. This is the most parametric advanced feature, and we'll be going deep inside that under this constant and equations. So what is that constant, how you can use this? And before, when I started learning in maybe in release 13 in late 1996-97, at that time we used to have release 12 and 13, and there in some of the applications like earlier version it was only DOS supported, and there you forget about the constant and equations. You were only able to draw the lines, arcs, and then join and get the drawings. But here we are talking about the constants and equations, which is very advanced and found in before maybe 5 years before, available in top solutions like CATIA and the Creo, NX, etc. So here we will get all the advanced options how to. So let us start with our learning objectives. We'll look at the geometric constants. What is geometric constant? How to apply? Control the display of constant. Apply constants automatically in an automatic way. How to apply? apply dimension constant as well. So other than this geometric constant, the another important aspect is your dimension constant. So how to distinguish between them, how to apply and when to apply which one, convert a dimension constant into an annotation constant and create equations. These are our agenda learning objectives. Let us start understanding the geometric constant. Geometric constant is nothing but in AutoCAD you talk about entity. When you talk about entity, let us say you have one entity here. This entity is AB. And when you apply a constant, here we are talking about the horizontal constant. What happens is, this is in space exactly, in coordinate system. Here and here you have a typical length, whatever the length may be. But when you fix horizontal constant, what happens is this get converted into horizontal, and it cannot, you cannot change this particular, this position other than this horizontal, so that will be logged primarily. So when you talk about this particular condition and you talk about this location locking, and when you apply the horizontal, this will be locked. Let me show you what I mean by this horizontal, and like that, this horizontal you have the vertical as well. So you can see this is the entity inclined line, and when you apply, this will be converted to vertical symbol, and when in case of horizontal, this will be converted to this, and you can see one symbol here also according to your type of constant which you apply. Let me show you what I mean. From your exercise file you can find this particular file, and this is in the particular chapter which you can find this in the chapter 11, which is talking about the advanced constant and all. So before adding the constant, the first entity or object and second entity was something like this, and after adding the constant I will show how you can see the difference. So let me apply a typical constant which is known as the horizontal constant, and these are the constants available, you can see, and this is the horizontal constant, and I'll apply a horizontal constant to this particular item, and maybe to this I'll apply vertical constant. So I'll just double click to activate this, and I'll apply the horizontal constant to this, and then I'll apply the vertical constant to this, and you can see now when I'll try to move this end maybe to this particular end, or maybe this particular end I'll move. What is happening here is, you can see directly they are logged, and they are symbolically showing here with this symbol, that here you have a vertical constant and here you have a horizontal constant. It's very easy to fix it. And by default, if you don't apply this, let us say we'll go for a line and create one line, and what happens is, if you hold the middle grip, you can move it, and if you hold any end, you can in fact rotate and reshape and resize that. And this is the power of this constant and parametric tab, you can see, which is introduced, and these all geometric constant you can assign to fix the location or orientation or type of object you are looking at. And another thing I'll show you here is, if you see this end I can move it, and this end also I can move it independently. But if you look at this particular constant, which I personally use most of the time, and if you click this particular end, this red highlighted, and this end, what happens is these two are now integrated at that point, and when you try to move or maybe move this, the whole object is going to move, and irrespective of the type of the height or whatever you talk about. So here you can lock this particular location by assigning this particular coincident. Or maybe if you try to see this particular case, I'll just copy it again, and maybe here we'll fix it, and we'll go to coincident, and this particular point and this particular point I need to consider, irrespective of the angle, and wherever they are, the positions, they will be locked. And now when you move this, what happens is, you see this is attached, but still angle is moving, but it is fixed here. Whenever I'm moving this also, it is fixed. So there is a relationship between these two ends. So this is what I was discussing about this particular coincident constant. And next we'll move to the fixed constant. This fixed constant is mostly used when you try to fix the location, and irrespective of where they are, irrespective of the coordinate reference, if you just want to fix it, then you can directly do it. And next is perpendicular constant. The perpendicular with respect to this two entity, when you apply this will be 90 degree, and this is known as the perpendicular constant. And how to apply that, that also will look inside this. And I'll just clean up all this, and I'll have a second set of copy here for explaining this, and maybe another set. Okay, so if you go for this particular perpendicular constant, and this is the object number one, you can see select the first object, and here you can see select the second object, so they will be coincident. And now we learn how to apply the coincident constant. So with respect to this point, I need to match this one. So here we applied, one is coincident constant, where you can see when I hover my cursor, here you can see the end, and one is the perpendicular constant. This both we applied simultaneously to cater to our exact requirement, how to reshape and give the exact position, orientation, and location based on this particular geometric constant. So we learned how to apply the coincident constant, we apply how to apply perpendicular, we also learned the horizontal, and we also learned the vertical. Now I will show you what is this fixed constant. So if you go for this fixed constant and you select your object, what happens is when you try to move this, what happened with respect to that particular location, it is fixed. So there is a pivot point. So let me undo this and go to fix and select this object, and again I'll go to fix and select this object. These both objects are now fixed. And now to better understand this, if you directly go for a coincident constant with respect to this and this, and now if you go for moving this or anything, you see this is not allowed because this is already fixed. Whatever the locations or whatever you have applied before can be locked directly. So for locking the locations without knowing horizontal, vertical, or maybe the angular locations, you can lock, and later on you can apply. Suppose you go for an angular one here. Here you can see the angular, and if you go for the angular and try to apply this here, you can see this is the typical 53 degree. If you try to change this to, let us say, 60, that will be automatically updated, because with respect to the locked location you can assign a new dimensional constant to resize and reshape, but this is locked with respect to this object. This is what I was trying to convey. And next we'll look at the parallel concept. And parallel concept is very important because in most of our geometry, what happens is when you have two different or a set of objects where you need to keep this distance fixed, and that is nothing but the parallel, and how to apply that, this constant can do it through this parallel constant application. And next we'll look at the collinear, and collinear I was discussing before also, and the collinear constant is nothing but it will make the two objects collinear, and before we saw the coincident also, and how to apply this, that also will look, and concentric options also will be looking at. To better explain you, this is a very mostly commonly used object. Here you can see the coincident, and here you can see this particular option known as smooth, another is parallel, and perpendicular already we saw, and this is collinear, which is very near to this one. So what I mean is, if you have object 1 and you have another object 2, you have another object 3, and you go for this particular option collinear and you select, here you can see the first object, here you can see this message, and I'm selecting the first object, and here you select the second object, and so on, and I'm going for again collinear, first object and second object, and next I will go for this coincident and select this end to this end, and again I will go to this coincident and select this end to this end. Then you can see how we applied the collinear and coincident simultaneously to fix it. This is one aspect, and another aspect is the concentric. Suppose you have multiple circles, and here you have a requirement to make them collinear, and before that you can fix the dimension as well, but later on also you can do it. So if you go for this collinear and this concentric, you can see the difference, and concentric is only applicable for arc or circular object. So this is the select first object, select the second object, that's it, and select the first object and select the second object, and so on, and you can fix your dimensions as per requirement, and you can hover and you can change also if you have not fixed the dimensions. And now these all the circles are concentric to each other, and there is a single center, and when you move it, they will move as a single object. If you move also one circle, what happens is it will move as a single or set or group. This is about your concentric features. And next we'll look at the tangent, which is very popular and mostly used feature, because in most of the cases you need to fix or maintain your tangency, and how to do that, that can be better understood through this. So if you have a entity 1, this is your entity, and primarily this is circular entity, and this is your state object, and even in fact this can be applied to another circular object also, and you can maintain the tangency like this. So this is the first object and this is the second object, and how the tangency can be maintained. Or maybe if you have multiple objects, object 1, object 2, and object 3, and in this way also tangency at 3 different points also can be maintained, tangency 1, tangency 2, and tangency 3, and so on. So this is also one of the very widely used option known as tangent constant. And next is symmetric constant, which is also one of the widely used option, which directly can save your time, just like your mirror. What it does is, let us say this is one profile, and you want to make this symmetric with respect to this existing line. And when you select this line and select this particular point, what happens is this will be directly symmetric with respect to this, and you can create this also. And equal constant is also very useful, because if you have a particular circle, its radius is, let us say, r1, and its value is 4, and another circle you have, if you apply this particular equal constant, so automatically this will be also 4. And just like that, this can be applicable to two lines as well, where this length is, let us say, 2, and its length is something else, and when you apply this particular constant known as equal constant, they will be equal. So let me show you what I mean by. Let us start understanding this concept which we recently learned, and we'll be looking at this tangency constant. So let me start using two set of objects and one line. And if you go to this particular tangent and you select your object number 1 and object number 2, they will be tangent. Just like that, if you can select this and this also, they will be tangent. Let us say you have a three set of objects, and how you can apply this, this also subsequently object 1 and 2, again enter to execute the same command, object 1 and 2, again object 1 and 2, and in that particular way what you can do is you can sync multiple objects which will be tangent. Now after applying tangent, if you move this object, you can see they're good able to rotate, but still the tangency is maintained. And once you fix this, then they cannot move it. So all this constant collectively how to use, that we can see in a particular project, and you can get the concept clearly. Let us say this is one object and this one object, it is having certain radius, and let us say this radius you can measure also, and let me say this radius value is 10, and I want to apply this radius value to this. And when you go to this equal constant and you select this set of object, the equal symbol is shown here, as well as they will be maintained. Just like that, you can also apply to linear objects. And let us say this linear object's dimension is something which you can measure here. I'm just going for 15, let us say, and you can also position this properly. And this is, I think, central distance. So we have to carefully select this linear. I picked midpoint, I think, this 30. So what you can do is now you can select this object and select this object, and they will be the equal. But here you can see this object is horizontal, but this is not horizontal. But if you measure, the distance are same. So that is the intention behind this equal symbol. But what about the symmetric? And you can see these two curves, how they are symmetric. You can see this through this particular example. If you hover the cursor, you can see this. So what I will do is, I will try to define one center line for referring, and another line this way, another line this way. So when you go for symmetric, so select the first object. Okay. So you select the first object and you select the second object. And next you select the symmetric line. And when you pick that, they will be automatically symmetric. And if you can measure this particular angle, I will show you what I mean. This is the angular constant, and if you try to measure this, and again if you try to measure this, they will be same. So that is the intention behind your symmetric constant and how you can apply. And then again you can resize this and you can trim and you can get whatever looking at. Let us say I'll level it. I will extend this, EX double enter, and just like that I will have my reference here and I'll have my reference here. I will extend this and I will extend this and I will press the shift so that I can trim this. So what I can do here is I can directly derive symmetric objects by using this particular reference. And one important aspect is, if any time in future I change this, what happened is, irrespective of that location also, it is updated and is changed. So if you fix this particular center line, you directly go for fix, then what happens is, if you try to update this, maybe this, with respect to this only this is going to update, and the whole scenario of locking is done. And here also the 33 is painted, you can measure it, still that is 33. So if you move also, so that is the benefit of symmetric constant, and that you can directly check and apply to your objects. Let us now discuss about this smooth content. This smooth constant is nothing but can be applied to a spline or a critical shape object where you need to join two curves, and that will be very handy in case of that particular option. Then we'll be looking at the constant setting and automatically how to do that. Let me draw one spline by going to SPL, enter, and this is my first spline, and I have another spline here, you can see, where they are completely tangentially oriented in different way. And when I'll go for the smooth and select the curve 1 and select the curve 2, what happens is automatically they are smoothened and oriented and accordingly fixed with respect to these two different splines curves conditions. And let me show you what is auto constant and how you can apply this. Also applies multiple geometry constant to the selected objects. For example, if you have one rectangle, let us say, and you select your object and go to auto constant, automatically you can see the parallel and horizontal locked and perpendicular features are applied to your object. Just like that, if you have multiple circles but not concentric, and in fact why I'm showing you is, if you try to move this, this can be moved, but when you select this and go to auto constant, automatically all these default constants are applied here. Just like that, if you have a particular object and you try to select this and go to auto constant, nothing happened, because here the tangency or so many possibilities are there. But in this particular case, that can be done. Or in other words, if you have like this suppose, and you select this and go to auto constant, tangent is not applied because this is not touching here somewhere. And if anyway I'll touch this particular object, then I can do that. If we go to move, and I will move the midpoint, and I will put it at this particular point, and when you will select and go to auto constant, what happened? If you try to move this, still this is not applied. So this auto constant is valid in most of the cases for fixing the basic thing. So still you have to go for some more constant to apply this properly. But in many cases that will be handy and it can save your time, and you can directly get it like the one which I am currently showing. One feature which I want to show you is under this geometric panel. If you can see this small arrow constant setting option, if you click this here, by default this option will be switched off, infer geometric constant, and what all different constants are there. So if you go for infer, and here you can see the dimensions and auto constants, what are the auto constants are there, this all you can activate and you can remove also, and this you can reset as well. By default the equality is not available. But let me show you what I mean by this infer geometric constant. Now after taking this inferred constant, and if you go for a rectangle and draw it, what happens is automatically this is drawn. If I'll go for this multiple circles around this, nothing happens. So for this again applies to some of the basic features like this which I'm showing currently for this rectangle, or maybe for the standard shapes. Let us say I'm drawing one line, this automatically horizontal is applied. I'm drawing another line, you can see the coincident feature also is applied, and the vertical feature also is applied. So like that this will be handy, and you can directly select these options for configuring that directly. So this was the case where the constant setting dialog box with the geometric tab chosen can be configured. And let us look at one project where we'll be configuring all this and how to do. So this outer loop of the sketch is something like this, and we'll be applying the sketch all default constant, and then we'll be doing that symmetric, and after doing that symmetric you will position the holes and also the slot, and we'll apply the constant to that, symmetric with respect to this and tangent with respect to all these side holes, and then we'll be positioning the other holes, or you can say the symmetric, and then we will go for this constant automatically, and you can also go for the user defined constant if you need, like the expression and all which is shown. And then in project 2 we'll be looking at this particular sketch where we'll be applying the all the constant which is shown here. So we'll be looking at the geometry constant as well, and I was discussing and I was showing you during the equal and the radius also how to use that constant and typically get it through the automatic applications, and then fix the values, and then you can add the typical constant or the distance or the relationship which you have, and then you get your final output. Let me show you this particular project which I was discussing, and then I'll be looking at its complete output how to create, and I'll just give some basic tips and trick how to handle this. So if you see this particular dimension, the primary dimension here, we'll look at all these sub dimensions later, but this is 4 by 1.64 rectangle, and from there we'll derive rest of all the objects and by referring the dimensions and slot locations, etc. So 4 by 1.64, this dimension you have to draw. I'll go to rectangle and I'll go for 4 by 1.64, and if you double click you'll see your object here, and here you can see all the constants are applied, and now you are safe with the positions and all. And now we look at this slot, and this slot is typically 1.64 minus 1.27, and this width is 0.74. So how to do that? 0.73 and this particular calculations. So this you have to directly do through the mathematics directly inside the box, and I'll just show 1.64 and 1.27. And what I can do is I can directly go to a line and take one center line here. I'll go to midpoint, and this length is nothing but 1.64 minus 1.27, and if you go for this, it's showing red highlighted. And how to do that? That is the pivot point. So just you cut this, and I will show you the trick how to do that. You go for fit CAL, and this expression you can directly go for this and go for enter, and now you can see that value is shown here. Just like that, I will lock my locations and I will go for fit CALC, and I'll specify the values. Go to fit CAL, and expression you type your values, whatever. Maybe this, so we have to again redo it. Go for a line that is from the mid, and go for fit CAL for calculating within, and 1.64 minus 1.27, and this is done. And you can see this is the width. And in this way directly you can fix the typical width whichever you need to calculate, like this minus this is this height, and again 0.73, and 0.73 also offset I need by 2. So how to do that? So again I need to go for an offset, and this offset distance is nothing but, again I need to calculate CAL 0.73 divided by 2, and select the object, and side to offset, select the object, side to offset, and now this is 0.73. And now you can connect this particular lines, and you can also trim the unnecessary portion, and just I'll join this, and this line I can use for my referring the center line, and that's it. And now I can select all my object and again go to the parametric features and go to auto, so that this will be applied. So in this way, if you can see this particular figure where we have these dimensions and this particular ratio is of 0.91, and how to apply this, all logic is behind two things. One is your dimension and its calculations, and another is your constant. So here the sum of the dimensions you can directly apply, like between this to this, whatever the dimension you have, and this you can enter. Go to the linear, and this to this, and you can have your dimension, enter, and so on. So this is the basic preview how you can apply and create, and then you decide and locate it. For example, if you go for a circle where the dimension is 0.35, and this is from this end at a certain distance, and if you go to linear and you go to this and this, you can see this is the height, or this is the horizontal, and you can fix this as well. And you are looking at, let us say, 0.8, and this will be set. And also this particular width you have to lock to 4, and this is also very important again. And again these two sides you need to keep it symmetric, and go to symmetric, and this is the first object and this is the second object, and this is the third object with respect to which that will be symmetric. So all these things when you maintain, then you don't need to worry about this. Again, you have to specify the dimension or the radius for this, and that again you have to fix it and finalize it. And anytime if you want to reorder this maybe 2.2, that will be done because all are parametrically controlled and positioned. This is not just drafting, but this is parametric drafting, so that in future any changes you want to incorporate, that will be done immediately. And just like that, if you want to incorporate here a particular line, then how to do? So if you go to the line, and from this point I need to have it a height of 1.1, let us say. So from this point what I can do is at the rate, in x direction is 0 and y direction this is 1.2, and when you click this going somewhere. So if you go to line and go for from, and now the base point is this, and the base point offset is something at the rate 0 in x direction and y direction 1.2. What happens is directly this comes and sits here. Just like that, this end reference also from here at a particular distance of 0.75, that also can be done. And now you can directly trim this reference which you don't need, and you can extend this also if exactly you are looking at, shift and trim this and so on. And now when you go for again applying this auto constant, then the constant will be applied here immediately. So like that you have to find the way which is the best to configure and balance geometric dimensions and the dimensional constant. So this is the geometric constant and the dimension constant. So geometric dimensions, these are the two different protocol, geometric and the dimension. So you have to balance both the thing to completely fully constant the object. And now we'll look at our deliverables. So our deliverables are all the module soft copy DWG files where applicable, lifetime support through our technical doubt session through the forum support, drawing PDF soft copy, tips and tricks, and all modules video license file. Thank you for watching this video.